Hey folks, Drew here. I just have a quick little video on how to do a specific type of probability problem that are called combinations. Now the word combination is used kind of fast and loose in a lot of word problems, but specifically here we want to talk about combinations as a way of selecting items from a set. And the important thing to remember with that word combination is that order doesn't matter. And the way that I remember that is that with a combination, CD, combinations, order doesn't matter. C, combinations, doesn't matter. CD, doesn't matter. Okay? Now, what does a combination math problem look like? Well, here's an example. How many different groups of 3 superheroes can I make from this list of 6, right? We have Spider-Man, Hulk, Iron Man, Captain America, Thor, and Doctor Strange. And we want to know how many groups of 3 that we can make from this list. Well, I could have Spider-Man, Hulk, and Iron Man. I could have Hulk, Iron Man and Doctor Strange. I could have Thor and Spider-Man and Captain America. I could try to make up a list, but I might reproduce some or I might mix some. But let's analyze it. Let's pick 3. Let's pick Hulk, Iron Man, and Thor. All right, so that's our group that we're picking. We're picking these 3. In fact, I'll even put let's put a check mark by them here. I'm picking Hulk, Iron Man, and Thor. So that's one group. Now, I have to ask myself, is this a combination? Does the order matter or does the order not matter? Well, I'm just picking them, right? So if I picked Hulk, Iron Man, and Thor, and I just sort of rearranged them a little bit. If I change the order, if I have, Iron Man, Thor, and Hulk, that's still the same 3 people, right? Changing the order doesn't change the selection, doesn't change the grouping, right? So Hulk, Iron Man, and Thor is the same as Iron Man, Thor, and Hulk. So what we've decided then is that order doesn't matter because it's the same 3 superheroes no matter what order I put them in. The order doesn't matter in this type of problem. So we've identified it as a combination. Now what do? How do we calculate the answer to the question, how many different groups of 3 superheroes can I make from this list of 6? Now here's the easiest and most straightforward way to do the problem. We're going to use a GED calculator, right? The TI-30XS. But first, we've already done the first step. We've identified that it is a combination because the order doesn't matter, CD. Our second step is we're going to write down this new special notation, right? And it's NCR. So we're going to write that down on our paper. Little n, capital C, little r. And what do the letters mean? Well, the C in the middle stands for that it's a combination. The N has a special meaning in this type of problem. That number that goes out in front is the pool size from which we select. How many total number of superheroes did we have? On the back side of this notation, I don't want to call it an expression because we're not going to really do anything with it, but on the back side of this notation we have an R, and that R stands for the group size. How big is our selection? How many superheroes are we choosing to put in a group? All right? So we can easily see those numbers in the problem, and that is our next step. We're going to identify those numbers and put them in front of and in back of our little expression NCR. All right, so we're going to find the pool size first. How many superheroes did we have from which we could select? Well, our list was 6 superheroes, so that's our pool size. We're pooling from a grouping, not a grouping, but a total of 6. That's what we could choose from. How many did we pick out or choose? We were choosing groups of 3. That's our group size. So that number goes afterwards. So once we've identified that it's a combination, we pick out our pool size, the number from which we're selecting sort of the total, and from that we're selecting 3. That's our group size, groups of 3 from a pool of 6 superheroes. And really, once we have that written down, our next step is simply to pick up the TI-30XS calculator and put this notation in and get an answer. Well, how do we do that? Well, let me switch over to the calculator. So if I switch over to the calculator, here's how we're going to put that 6 NCR3 in there. First, I'm going to put that pool number 6. There were 6 superheroes. The second thing I'm going to do is I'm going to hit a new special button, which is the PRB button right up here. And when I press that, you can see it in the keystroke down here, the PRB button. And it turned red up here. And notice what happened. In my display on my calculator, it displays a little menu. And really what I'm concerned with is these choices. First choice is NPR. The second choice is NCR. The third we're not going to use. What was our notation? Our notation was NCR because this is a combination. Now, how do I select that? Right now it's defaulting to the first selection. So I'm just going to go to number 2. And I'm just going to hit the number 2 on the calculator. And it goes down to that selection and it automatically displays now on my screen 6 NCR. And it's waiting for me to put in my group number. My group number is 3. So all I hit was 6 PRB. I selected 2 because it was the NCR, and then I just put in my last number here, which is the group size 3, and I'm going to hit enter. And we get the answer that there's actually 20 different groups of 3 where the order doesn't matter that we can make from those group of 6 superheroes. So that's how we do a combination problem. If the order doesn't matter, we're going to use the NCR function, and then you just pick out the group size, right? The group size and the pool size. The pool size is from the number from which we can select, and the number that we select is the group size. And we just put it in the calculator like that. 6, hit that PRB key, select 2 for NCR, put in the 3, enter 20. And that's how every combination problem will work, and you will get the correct answer. Sometimes the numbers might be a little scary because we use small numbers. If we use big numbers, it'll get big really quick because there's all sorts of different combinations that we can make. But again, combinations, the order doesn't matter. Thank you.